back at the Amherst kitchen table of Hampshire College astronomer Dr. Salman Hameed, Mr. Universe, the head of Kainat Studios, who, when we last spoke, helped us commandeer a galaxy for the 413. Hooray! We don't only have our own day and our own galaxy.
NGC 413.
NGC 413 is the name of it, so go look it up. It's ours now in the Salman International Galaxy Registry. The other exciting news story that came out just in the middle of last week is that we found aliens.
And that's the reason I'm wearing a shirt with UFO on it.
It looks like a flying saucer painted in a Van Gogh style, but it says "Believe" and New Mexico. I've been to Roswell. You've been to Roswell too, right?
Yes.
I didn't see anything.
You didn't see Van Gogh?
I didn't see Van Gogh or aliens.
All right, so there is a big story that came out. It was in the New York Times as well, and was covered at other places. And the story was about an exoplanet. So these are planets orbiting around other stars. There is a particular exoplanet which is numbered K2-18b, small b.
Bingo.
Exactly. And so that K2-18b, it's about that star is a smaller star than our sun. Those are called red dwarfs, but those are the most common stars in the universe, much more common than our own sun. And there is a planet that we know that orbits around it. It's a planet that is bigger than the Earth. It's about 8 times or 9 times more massive, 2.5 times bigger in radius. So those are called like mini Neptunes or super Earth, however we want to say it, but most likely mini Neptune. This category of planets does not exist in our own solar system. Mm-hmm. So we have Neptunes, we have Uranus, we have Jupiter, Saturn, and we have terrestrial, like rocky planets, smaller. But these type of planets, astronomers are finding in other solar systems, but we don't have it, that example. So in this particular case, this planet is orbiting its star at a distance which astronomers call a habitable zone, meaning to say it takes 33 days for this planet to go around its star, but because the star is a little bit cooler than our sun, it is at a distance where water can stay in liquid form. So it was
not too hot, not too cold, just right. The Goldilocks zone.
That's exactly right. And so there was already interest in there that, hey, okay, so this is orbiting in a interesting, or what astronomers look for, something like, that, hey, water can be in liquid form. It doesn't mean that it does, but there's a possibility. So it's in the habitable zone. And we knew that it has a thick atmosphere, or a puffy atmosphere. Now, this is crucial because it was detected by Kepler Space Telescope, and the way many of them, or majority of the planets that have been discovered, by the way, close to 6,000 planets now, 6,000 exoplanets, but a majority of them have been detected when a planet goes in front of its star. So there is a little bit of starlight dips, and we say, it must be a planet out there.
Because you monitor it, you can see how long its year is. It comes back regularly. Once you can predict, it's 33 days. It's going to dip again in 33 days. It does. They say, confirmed, exoplanet.
That's how you confirm it. And so this is called eclipsing method, because the planet is actually eclipsing the star. So, but you also can imagine that you detect planets in this way when you have a particular orientation. So what you would call an edge-on system. Because if it's sort of like, in a different orientation, if the planet does go around the star, but it doesn't, for us looking at it, if it doesn't eclipse it, we're not going to detect it with this method. Mm-hmm. So, but here is the cool thing. In many cases, when the planet goes in front of the star, you have the ability to potentially look at starlight that is passing through the atmosphere of the planet. Mm-hmm. And when the light gets absorbed, so this is the starlight that we are seeing, some of the light gets absorbed by certain molecules. Those molecules are in the atmosphere of the planet. And you can actually tell sort of like, what is in the atmosphere.
Because of the color, right? Spectroscopy. Because different gases look different colors in different lights. And this is part of science. They look the same through the light on this planet as they would on a planet that's how far away is this?
This is about 120 light years away.
So if they see the color on this planet, they say, aha, this is this molecule. But then they see the same color on that planet 120 million light years away, same molecule.
And more than a color, you can actually look at a particular pattern in light. So that's where spectrum comes in, and that's where spectroscopy comes in. And these molecules have particular absorption signatures, meaning to say they absorb light in a particular way, and you can say, aha, this must be this molecule in there. So, for example, in this particular case, carbon dioxide had been detected in the atmosphere of this planet, and it was interesting. This planet had sort of okay, well, it has puffy enough atmosphere that when this planet goes in front of its star, we can actually make measurements of certain gases that we can detect. Mm-hmm. And so there was interesting, and there was a debate going on because some groups have claimed, and so a lot of that stuff now you can do that with James Webb Space Telescope. James Webb Space Telescope is designed in many ways to do measurements like this. And so there was detection, and there was a claim that perhaps there is a liquid water ocean on the surface. So you have hydrogen-rich gas. So in this particular case, we knew that there is hydrogen there. And then maybe there is a liquid water ocean there. And it was dubbed as a Hycean world or Hycean world, hydrogen and ocean.
Not high C, the old fruit drink.
No.
That would be awesome too if a planet was made out of just like a sun-kissed planet. Sunny D.
Here you go. Here's your corporate sponsorship for NEPM.
Look at the beautiful Capri Sun.
So there was this interest in there, because if there is ocean there and then there is this thick atmosphere over there, maybe and it's in the habitable zone, maybe there might be life over there. So the article, this is a long way to come to the actual story why this particular system was in the news. There was a New York Times major story written by Carl Zimmer, who is a biologist who actually writes very well, especially in terms of thinking about biology and stuff like that. And the article talked about a new paper that came out by a researcher at Cambridge University. It was a study led by a researcher, Niku Madhusudan. And they claimed to have detected a particular molecule, which is considered a biosignature. So remember, we cannot go there. All we can look at is what's in the atmosphere. And one of the claims in that paper was that they have detected dimethyl sulfide, or in short, DMS. And the detection was important because this particular molecule in the Earth's atmosphere is only produced by phytoplankton or algae in the oceans. And so if we see dimethyl sulfide, and this is the claim in the paper, in another exoplanet's atmosphere, it might be a sign, an early sign. You can think about maybe there is some sort of life maybe there, because on Earth, dimethyl sulfide in the atmosphere is only produced by life.
Dimethyl sulfide, DMS, only produced by algae or life on this planet. So this planet, 120 million light years away, DMs us.
That's right.
Hey, I'm alive. What are you doing tonight? Slide into my DMs, DMS.
Oh, yeah. Okay, did not think about that, but yeah, it is possible. But here is the problem. So this became a huge news, and in fact, I would say as you can imagine, and to be honest, we have talked about it, detection of life, even if it's microbial, is going to be one of the biggest discoveries of humanity. And so this is a reminder that here is somebody has made a claim, but unlike UFO claims, unlike UAP claims, whatever you want to call it, unidentified aerial phenomena and so on and so forth, how science actually works. So in this particular paper, they did say that their detection level is a little bit less. So, for example, it's what's called a 3 sigma result. The scientists claimed, the ones in that paper, that there is still a 0.3% chance of this observation to be a fluke. And which is, for science, for astronomers, for physicists, it's actually a pretty high level of uncertainty, because you want what astronomers call a 5 sigma, where it goes to about a million chance of being wrong. 0.3 is still pretty high. And so in the last week and a half or 2 weeks since this story actually started to come out, there have been other people who are looking at the results, and there is a lot of pushback that is coming in. And in fact, I would say this is a beautiful example of how cutting edge science happens. People who are challenging these interpretations of these results are not people who say, I believe there is no life in the universe. Everybody thinks that it would be an amazing thing if we do find life. Even if somebody else finds life, I think everybody believes that this would be really cool. But when you have such a big claim, then you have to be you have to be skeptical about what is being claimed, and are there alternative explanations to that. And this is exactly what's playing out. And in fact, now there are other groups that are claiming that, well, this particular claim may not be as strong as it was initially made.
So that's a little bit of a bummer, but this goes to show you how science works. You can be as skeptical as you want about anything, even if you run major departments in the United States government. But when all sorts of people come out with all sorts of studies, you have to believe it, even if it counters your hope.
Right, and so it's wishful thinking doesn't take you anywhere. What is there is there. You can actually make it illegal or whatever, that doesn't do it. So in this particular case, what's going on is, I actually recently talked to a Sagan postdoctoral fellow, Ryan McDonald. Actually, if you go on Kainat English, you can actually find this 20-minute conversation with him. He actually works on exoplanets and is critical of these results. And one of the things that came out of that was that, first of all, the 3 sigma result, well, people are saying even that actually is a little bit higher, because you have to create models to figure out what kind of gases are going to be in the atmosphere. And remember, we do not have a comparable example in our solar system.
Right.
So you are looking at something that we have not observed closely, but we have to predict what kind of combinations of gases are going to provide signatures that you are seeing from the starlight passing through the atmosphere of a planet 120 light years away. This is not an easy thing to do. And so there was a little bit of a challenge in terms of very specifically how they got to dimethyl sulfide, because again, the claim was maybe there are other kinds of gases that can produce a similar type of signature, and maybe it is not being produced by dimethyl sulfide. So that is one, and that's where the 5 sigma really high-end result is crucial, which we are not there yet, even by the admission of the people who wrote the original paper regarding potential biosignature detection in this particular planet. Now, the second thing that say is that, well, there is also a debate whether there is an ocean there or not. Because you have to think about the context. So even if you detect, say, for example, a particular molecule which on Earth is produced by life, first of all, you have to know, well, is it produced someplace else without biology? And as it turns out, yes, because dimethyl sulfide has also been observed in comets, for example, where there was no life, and yet it is there. So you have to say, okay, all right, but what about the ocean? Well, there is also a debate whether what you see in there can be explained by, for example, a magma ocean rather than liquid water ocean. So if you put all of these things together, so you cannot just use one molecule, for example, to claim that it's a biosignature. Well, it may be a biosignature, but first of all, it could be from other biology. You are looking at another planet. But also, what is the surrounding context in which that is being produced? And so this is still early, but the concern is, as we mentioned, this is how science works. This is how pushback comes in. Another researcher has actually reanalyzed the data. Now, this data had not been public yet, meaning to say if somebody writes a proposal for James to use the James Webb Space Telescope, the people who get time on it get a year of what is called proprietary data, meaning to say they get a year to work on this data before it gets public, meaning to say anybody can then look at it. And that time ended just last week. April 26th, a couple of days ago, is when the data became public. So now other research groups are going to look at this same data and analyze them in other ways and test it out whether dimethyl sulfide is really there or not. So that's where cool science part comes in, is that somebody says, well, hey, this is a really cool potential detection of life. And other people say, really? Let me double check it. I think it may not be the case. But we may find out in the next couple of years, maybe, because I'm pretty sure there is going to be more time on James Webb Space Telescope to observe this planet, because it is interesting. There is no question about it that this is an interesting system. They will get more time to really isolate not just dimethyl sulfide, but are there other molecules that, if there is life, they may also be present over there, and their absence may be puzzling. But if they come out to be that, yes, those are also present, we also go over 5 sigma detection from dimethyl sulfide, then it could be like, hey, we can still not say there is definitely life over there, but we can certainly say, now this is really interesting. But we are quite far from that point. And the problem is that most of the newspapers, the way they reported, most of the media that they reported was like, we might have detected life. And that's the problem of bad science, because this is not, we are way far off, and there are only so many times that we can claim we have detected life.
Right.
And so, great. I think this is a really interesting system, interesting observations, but quite far from saying we may have detected a biosignature. We may have detected a sign of a potential biosignature. Maybe that.
It's hard to put that into one catchy headline, so I understand how that can be tricky, but I also have had to actually literally correct somebody about this story, saying we did not find life on another planet.
And
we found one molecule of a thing that means life on this planet. We're so far away. And to credit the New York Times version of the story, there's a quote in there saying, unless we see E.T. waving at us, we do not have a smoking gun.
Right, and this, again, to me, the larger story in there, and we always bring back to it, because in 413, we are much more skeptical about UAPs and UFOs than the New York Times is, for example. That you just look at the carefulness, look at the challenges that comes in, and then compare those to, for example, some of the congressional hearings on UAPs, where somebody comes in and says, I've seen alien bodies. It's like, no, have you seen it? It's like, no, but I know many people who have seen it who I trust.
Yeah.
And then there is a whole congressional hearing about that, and that is even before the current administration. So I think this is a good lesson in how to think about science, how to think about these things, that something you have to test those claims, and this is becoming more and more important. And this is not just about astronomy, but also biology or health issues and other things.
Or any political issue ever.
Yes.
It gets more and more difficult, but keep skeptical, keep checking your sources, keep cross-referencing. It's the scientific method.
And be honest about it. And there is nothing wrong in being excited about the possibility. But the more you want to believe, the more you should be skeptical about it, because you can be fooled by it.